Well, now we come to what is geometry. I mean, although I'm sure it's very basic and most of us are conversant with that, but still, if you look at it, it is a science of the properties and relations of lines, surfaces, and solids. So basically, I am sure you must have gone through some kind of coordinate geometry in your education, and we all are conversant with the basics, but still quickly we'll take a look at it. See, a point on in the 3D space is just a point. It has, let's say, x, y, z coordinate with respect to a particular Cartesian system. And any such 2 points are joined with a line. And whenever there are about 3 points and connected to each other, they kind of form a plane. Furthermore, many such planes joined together as faces can be considered as a cuboidal or 3D rectangular piece. Other shapes we are also conversant with. Maybe there can be a donut kind of a shape. There can be a cylindrical shape, which is a combination of two circles and a curved surface area. There can be a cone, a sphere, or a curved pipe. Surfaces are typical. I'm sure people from the automotive industry, uh, when you take a look at a car external body, so all those smooth curves are there. So that is what I'm sure rest you guys will be knowing. And of course, let's say section of a complete circular donut is what is represented in the next figure. And this is again a circle or elliptical, or maybe you can say a racetrack kind of a shape. And I'm sure you must have also seen shapes like a typical gear, which is a combination of several of these various geometrical features. So this is just to cover, what we mean by geometry. And one may wonder, if not geometry, then what? Whatever is random in the nature, say sand dunes or maybe mountains or waves in the sea, they have some pattern, but they are not well defined, and they are kind of natural patterns. Uh, Whereas what we are talking about, these do not necessarily occur in this shape in nature, and mankind is kind of involved in making these specific well-defined shapes. So that's covering a geometry versus a natural occurring shape. Well, now we come on to dimension. A dimension, as we all know, but still we'll be covering it, a numerical value expressed in the appropriate units of measure and used to define the size, location, geometric characteristics, or a surface texture of a part. So it's a measurable extent as length, breadth, and depth. And these are a few, I mean, what we use typically in the engineering drawing, and the methods to show. So let's say this is a dimension of, though the units are not mentioned. So uh, in the bottom it is mentioned that it is millimeter, but you can uh, make drawings in any units. The two which are being globally followed are inches and millimeter. US industries are more prevalent and using inches system, whereas the European and the, let's say, Japanese or this world is more conventionally using the millimeter in the drawings. So these are various methods, uh, in the way various dimensions are represented on a drawing. Uh, so these are, except for the one with the circle, typically all these are, gaps or lengths or widths or depths kind of a thing. Whereas this is the top view of a circle. It can be a shaft or it can be a hole in a body also. So this is what is shown. Yeah. So decimal inch dimension on the right side, and on the left side we have millimeter dimension. So both are, still in practice, across the world. Now we take a look at various aspects or let's say the way we call it, anatomy of dimension. So the rectangular block where I'm moving the cursor, rectangular plus is a chop off of a edge on the lower left bottom side. So this is how a block, it's a metallic block, let's say, or maybe it can be wooden also, it's not mentioned here. But if a shape like this, if a solid shape like this, which is, so what you would observe that the body lines, are thicker in nature, and wherever there are symmetric shapes, they are, put with a this kind of a dash dot kind of a line, and this is how you describe a center line. And now if we come to the dimensioning part of it, so the value which is describing the length part of it, we make it as a mention in this manner, and this is the dimension. And the lines, the thin lines which will be extended beyond the body lines. So if this is the body line, you would notice that there is a slight gap, and there are standards about it. It's not that you can leave a long gap on one side and a short gap on the other side. So all these are standard conventions and which are being followed. It's a subject under covered under technical drawing. So I mean, once you know it, you practice it, and it becomes acceptable across the world. So extension lines are lines extending beyond the body lines, and joining the two faces or edges. You mark with these arrows, and in the middle you make a mention of what is the quantity. I mean, how much is the width or length of the part. For example, the total length is 40 here, and the hole is about its center. There are various methods of showing it also, but the way it is described, that this particular hole in the x direction, I'm sure we all know this is x, and y is from bottom to top side. So it is located at 20, and similarly the width part of it, the width of this component is 28 millimeter, and here it is not centrally located. If we take a look, this is at 12 millimeters from this particular edge. And to define that, now that we have defined the x and the y part of it, now we are saying that what is the size of it? It can be 5 millimeter, 10 millimeter, 12 millimeter, whatever. So this is another way of describing, along with the phi. Phi stands for sphere. So it's a circular shape, and it's a diametrical representation. So it has a diameter of 12 units, millimeter or inches needs to be ascertained depending upon the drawing, which is typically in the title block of the drawing it is mentioned. And if we look at this chop off, the small portion which is removed. So the location of the start of this is at 20 millimeter from the top edge face, and after 20 millimeter there's a chop off of 30 degrees of material. So the designer of this component has something in mind, which has to have a location that this chop has to occur after 20 millimeter. So tolerance is yet not covered in this. In the next coming slides, probably we'll take a look at that. So quickly recapping all these features. So these are the center lines, and these are the extension lines. The dimension is put like this, and through a leader we describe certain nodes, certain features, and angles are represented in this manner. All right. So having done this, we move forward. Now, as I said in the previous slide, it was not mentioned that what is the tolerance. So here we are going to discuss the tolerance. So tolerance is how much okay, what is the origin of tolerance? The origin of tolerance is that we know that despite all of our good efforts it is not possible for mankind to reproduce each part exactly the same due to certain variation in the material properties, the cutting tools and the forming tools and machines and environment and so on. Some variation is going to exist. And uh, one good way is to accept whatever is happening. Another one is to control it and limit it. And what will work the best for us is a rough understanding what we mean by the tolerance. So let's read the language, and of course you will agree once you read it. It is allowable variation in any measurable property. So be it temperature, be it length, be it pressure. So whatever is the quantity being measured or the property being measured of any part. So what is the allowable variation? And that allowable or not allowable depends upon the function of the part, the way it is going to perform, the way it is going to be working in conjunction with the other parts and so on, and the environment it is working. All right. So the total amount that feature of the part are permitted to vary from the specified dimension. This is additional understanding of the tolerance is the difference between the maximum and the minimum limit. Of course, uh, needless to say, but there's a nominal and there's a lower limit and there's a higher limit. And the total range of the value that is acceptable uh, as per the design function. So this is what we mean by tolerance. And maybe in the later stages we'll discuss at times, uh, nothing below a particular level is expected, and sometimes both sides. So we'll cover that in the next coming slide. Now, tolerance. Two common methods to specify tolerance. Limit tolerance. This is kind of plus minus tolerance numerical values expressed in appropriate units of measure and used to define the size, location, geometric characteristics or surface texture of a part. So this is what we have already covered. It is, you can have a plus or minus kind of whatever is allowable. It is a measurable extent as length, breadth, and depth. Okay, there can be others also. Tolerance can be applied directly to the dimension feature using limit dimensioning. This is the ASME preferred method. The maximum and minimum sizes are specified as part of the dimension. So if you take a look at this, so here it is mentioned that this particular part can have a range of from 3.49 to 3.53. So this is one way of describing where both the limits are put. The advantage of this is that anybody who is going to be using the part, looking at the part and working for it, he need not have any kind of a mental burden of calculation. Because, for example, if another way of describing, as we see, it is 22 minus 0.3. So this is a unilateral kind of a tolerancing, where somebody has to do a mental processing. Okay, 21.7 is the lowest limit, and maximum you can go up to 22. Whereas on the right side, if we take a look at it, we have 22 plus minus 0.2. So here you have both range. And so this was an example of a lower specification. Here, this is an example of upper specification where it is not. The part will not be acceptable or functional if the dimension which is described here is lower than 12. So only plus 0.1 of the unit is permissible in this case. And so by now we had a look at it, just the exact values which are acceptable. Then we had a look at lower tolerance and the upper tolerance and the mixed tolerance. And there can be one more, type that Here we saw that it is same on the plus side as well as on the negative side. Whereas if you take a look at this particular dimension in tolerance, here we have 22 millimeter, and on the plus side we have about plus zero point 0.1, which is the highest limit, and on the lower side there is a possibility of going down by zero point 0.2. So you can have non-uniform bilateral tolerance also. So on the left side and on the right side you have examples of it. We have already covered from the top to bottom. So this is the way it is organized. Unilateral, this one we have on the negative side, this one we have on the positive side, and these were the linear tolerances, these are angular tolerances.